All right, so today we're going to go over 4.2b, which is really just talking about those 6 trig functions, which you have learned about last year, okay? So our old definitions, like if you think about sine, cosine, tangent, you remember SOHCAHTOA, right? That's how we used to define it, opposite over hypotenuse, adjacent over hypotenuse, things like that. Well, now we're going to define it a little bit differently now that we know the unit circle. So if you think about the fact that sine is the opposite over the hypotenuse, and you just think about an angle on the circle, okay? So this is theta, right? We know that when you're talking about a circle, the unit circle, you're talking about r, right, being the radius from the center to the edge of the circle. Isn't this the value of y, and this is the value of x, right? And so now if you think about this theta, isn't this the opposite side, this is the adjacent side, and this is the hypotenuse? So that's where sine comes from, right? It's the opposite over the hypotenuse. Now, with our new definition, we're going to define it in terms of our circle, okay? So now the opposite is really y, and the hypotenuse is r. But thinking about the unit circle, the radius is equal to 1, right? So this is really like saying y over 1, which means that sine is now equal to y. Cosine was adjacent over hypotenuse, so that would be like x over r, which again, if you plugged in the r value of 1, it means that cosine is equal to x. Tangent is opposite over adjacent, so tangent is y over x. So we'll no longer, well, I shouldn't say we'll no longer, but we will also define sine as y and x and y over x, okay? Now there's 3 other ones. Now they're probably not new because you learned about them last year, right? But cosecant is the reciprocal of sine. So what that means is you can just flip sine. So cosecant is 1 over y. Secant is the reciprocal of cosine, so that gives us 1 over x. And cotangent is the reciprocal of tangent, so we get x over y. Okay? How I remember them is that sine and cosecant go together, and cosine and secant go together. An s and a c have to go together. 2 s's can't go together, 2 c's can't go together. So it's an s and a c. Okay, so that's the way you can remember it. And then tangent and cotangent, those are easy to remember, right? Moving on. Okay, so on your unit circle, there was a thing that talked about positive and negative signs. So we're going to talk about the signs of all of these trig functions. So have you guys ever heard the phrase like all students take calculus? Did you guys learn that last year? No, maybe not. Okay, it's okay if you didn't. All students take calculus, which is really a lie, but it's okay. For our purposes, we're just going to go with it, okay? All students take calculus is a way that you can remember the signs of the trig functions, okay? So first of all, you have to start at quadrant 1 and you have to go counterclockwise when you're saying the phrase, okay? Also, some people remember it as cast, but then you got to remember to start in quadrant 4. So it's your choice, however you want to remember it. Anyhow, this means that all signs are positive. So sine, cosine, tangent, secant, cosecant, cotangent, they're all positive. Okay, you cannot be negative in quadrant 1, which makes sense because the x and the y are both positive. Now for s, this is sine and cosecant. They are positive. Okay, in quadrant 2. All of the other 4 are negative. Tangent and cotangent are positive in quadrant 3. All other 4 are negative. And then cosine and secant are positive in quadrant 4, and all other 4 are negative. So now I need you to get out your unit circle, and we're going to add to it. Okay, we're going to put all this information there as well. So where it says positive and negative, we're just going to fill in those signs. Okay, we're going to fill in those trig functions there. So in quadrant 1, none of them are negative, and then all 6 are positive. In quadrant 2, sine and cosecant are positive, the other 4 are negative, and so on. So just go through and fill that in on your circle so you have all the information in one place. Can I move it up? And then in quadrant 3, tangent and cotangent are positive, the other 4 are negative. And then in quadrant 4, cosine and secant are positive, and the other 4 are negative. Okay, everybody good with that? Okay, so coming back to this, what we're going to do now is we're going to use the circle to evaluate. Now, hopefully, you are comfortable enough with the circle to kind of be able to do this in your head. But if you're not, we're just going to use the circle for help for now. So you need to be careful because sometimes when you get an answer of 0, if you think about the fact that there are 3 reciprocal functions, if sine is 0, then that means that cosecant has to be undefined because it's the flip of it, right? It's the reciprocal. So if you flip 0, you're going to get an undefined solution. So that's going to happen on the circle. So we're just going to look at some of this. So try to not look at your circle right now. What is the coordinate of pi over 6? Okay, now look at your circle. Look at your circle. What is the coordinate of pi over 6? There we go. Root 3 over 2, 1/2. Okay? So you should be able to recall that, like, immediately. Very soon. Very, very, very soon. Okay? Like, tomorrow soon. All right? Keep working at it. So then we're just going to go through. Now remember that r is 1, because we're talking about the unit circle. Sine is y, cosine is x, tangent is y over x, cosecant is 1 over x, secant's 1 over, cosecant's 1 over y, sorry. Secant's 1 over x, and then cotangent is x over y. Okay, so now that we know this coordinate, we're able to fill in our chart. Okay, so if I ask you for the sine of pi over 6, then your answer is 1/2. What is the cosine of pi over 6? Root 3 over 2, because it's just the x coordinate. The tangent of pi over 6 is y over x, or sine over cosine. So 1/2 over root 3 over 2. Now we cannot leave our answer like that, right? So we have to think about dividing by the square root of 3 over 2 is the same as multiplying by 2 over root 3. So what's going to happen here is these 2's are going to cancel. We're going to be left with 1 over root 3. You still can't leave your answer like that though, right? So we're going to rationalize it by multiplying it by root 3. Final answer should be root 3 over 3. Now, some students like to go through and fill in their tangent values on their unit circle just to remember it, because it does take a little while to calculate it if you don't know them by heart. Okay, and you'll see it's going to keep coming up. So hopefully we'll get there real quick. So the cosecant is the reciprocal of sine. So that means whatever sine was, we can just flip it, right? So we're going to get 2 over 1. So it's just 2. Secant is the reciprocal of cosine. When I flip that, I get 2 over root 3. That's not an acceptable answer, though. Okay, so you have to rationalize. So I get 2 root 3 over 3. And then for cotangent, I can flip tangent. Now let's think about the best place to flip. If I flip it now at the very end, where tangent, I had an answer, I'm going to have to rationalize again, right? But if you just back up one step, isn't this also tangent 1 over root 3? So can't I flip it there and just get root 3 over 1? So it's root 3. Okay? So you can find the reciprocal at whatever step you wanted. Like you don't have to go all the way back and actually put x over y. Okay? So if you did flip tangent from its answer, from root 3 over 3, you just have to rationalize again and simplify. Yes? Yes, I think we do. Correct. Yep. No worries tomorrow. You don't actually have to know your unit circle and be able to answer these questions until Monday. Okay? All right, so looking at this one, next one, you need to know the coordinate of 5 pi over 4. Now it's a pi over 4, right? It's a combination with a 4 in the denominator. So what kind of coordinates am I going to have? Root 2 over 2, root 2 over 2, right? So let's say we don't know our unit circle, but we know that. Now think about 5 pi over 4. What quadrant is that in? 3. So what are the signs of x and y in quadrant 3? Negative and negative. So this is negative root 2 over 2, negative root 2 over 2. Okay, well, what is sine? Negative root 2 over 2. Everybody agree with that? It's just the y coordinate. Cosine is the same because it's the x coordinate. Now tangent is going to put sine over cosine, but when I put something over itself, what am I going to get? 1. Okay. Now cosecant is the reciprocal of sine, so I have to flip this. So I'm going to get negative 2 over root 2, and then I have to rationalize it, so I'm going to multiply by root 2, which gives me 2 root 2 over 2, and it's negative. But those 2's cancel, so I'm left with negative root 2. What is secant? Same exact thing, so negative root 2. And if I take tangent and I find its reciprocal to find cotangent, what do you get? What's the reciprocal of 1? 1. Okay? Moving on. Okay, this one you should definitely know. What's the coordinate of pi over 2? 0, 1. Okay, so what is sine? 1. Cosine is 0. Now tangent is y over x, or sine over cosine. So it's going to give me 1 over 0. So that means that tangent is undefined. We talked about the reciprocal. We could probably fill this in. This got pushed onto this next page here, which is going to push all of our notes, but I'm just going to have to deal with that. When you flip sine to get cosecant, if you find the reciprocal of 1, it's 1, and the reciprocal of 0 is undefined. And then if I find the reciprocal of undefined, then I get 0, because I really get 0 over 1 here, right? And that's just 0. So this is a case where when you get that compass point, either pi over 2, pi, 3 pi over 2, 2 pi, you're going to have undefined solutions. Yes? For secant, you had to take the reciprocal of cosine, so you had to flip cosine. Now if you flip this, it's like 0 over 1 right now, so I get 1 over 0. The domain for sine and cosine are all real numbers. You can plug in anything for it. There's no limit on it. And the range goes from -1 to 1. And we'll talk more about that much later and really forever. So we'll just keep talking about all this stuff. We talked about the fact that if you just go around the circle, it just increases the angle, right? These coterminal angle idea, remember, you could just keep adding 2 pi every time or subtract 2 pi every time. You end up the same place, just a different representation of the angle. Well, the same thing goes for all of this. So if you think about sine of pi over 6, what is sine of pi over 6? What is the y value at pi over 6? 1/2. Okay, that's what that's asking. What is the y value at pi over 6? If I took pi over 6 and I added 2 pi to it, so then I got the sine of 13 pi over 6, which means I was here, right? The sine of pi over 6 is here. And if I add a full revolution, I'm at 13 pi over 6. Don't I end up at the same exact thing, so it's still 1/2, right? So this is just that same idea. Okay? These are called periodic functions now. Okay, it's the same idea as a coterminal angle, really. So the sine of an angle plus 2 pi, however many times, is still going to be the sine. Same thing with cosine or tangent or any other trig function. If you add a full revolution, you end up in the same spot. This is called the periodic function, and that is because the period for sine and cosine is 2 pi. So what I can do is I can take those full revolutions out, okay, when I'm evaluating this. So when I look at this, the sine of 7 pi, now 7 pi doesn't show up on the unit circle, but I can see that there are full revolutions within there, right? So think about how many times does 2 pi go into 7 pi? So couldn't I rewrite this like this, the sine of pi plus 3 times 2 pi? Right? There's 3 full revolutions in there. That's the 6 pi. The pi is what's left over. Does that make sense to you? So you want to think about how many full revolutions are there. And then you basically just disregard those, because it doesn't matter how many times you spin around the circle, you still end up in the same spot. So this doesn't matter. Okay? What we're really evaluating then is the sine of pi. The sine of pi and the sine of 7 pi are going to give us the exact same answer. So now you need to ask yourself, what is the y-coordinate at pi? Good. So our answer is 0. Now that was an easy one because it was easy to see how many revolutions, right? Because we didn't have to think about a fraction. When you introduce the fractions, sometimes it gets a little bit harder. So the first thing you do is think about how many full revolutions are in there. So looking at a denominator of 4, what is a full revolution represented with a denominator of 4? 8 pi over 4. Also, this is negative, right? So you can go backwards too. So how many backwards full revolutions are within there? 2. Because I can write this as the cosine of negative pi over 4 plus 2 times negative 8 pi over 4. Right, this gives me negative 16 pi over 4, which is 2 revolutions. This is the piece that matters. So none of this matters. I just disregard that. And I look at the cosine of negative pi over 4. Now, sometimes students don't like to look at it with a negative angle. It's confusing to them. If you don't like the negative angle, what can you do to make it positive and be the same thing? Just add 2 pi. The idea of a coterminal angle, if I don't want a negative angle, I can add a full revolution, right? So if I take this negative pi over 4 and I add 2 pi, which is the same as 8 pi over 4, then isn't this the same as the cosine of 7 pi over 4? Right? Or you can think about the circle. If you had a cosine of negative pi over 4, that just means you got to go backwards pi over 4 units. You'll notice that that is 7 pi over 4. So now you got to ask yourself, what is the x value at 7 pi over 4? Root 2 over 2. Yes?
So why do you multiply by the 2 times the negative?
The 2 represents 2 revolutions that I can take out. So 2 times this negative 8 pi over 4 is like negative 16 pi over 4. Plus a negative pi over 4 takes me to the negative 17 pi over 4. Okay? So you want to take out those revolutions or those periods that are within there. Okay? Any questions? Okay, the next idea is a big idea, and it comes up like very sneakily forever. So we want to highlight this one because it's going to come back, okay, a lot. So this is something you definitely need to know. Also, you need to know the period and the domain and the range. But those are just going to kind of keep coming. This you definitely want to memorize. And this is actually going to take us back all the way to, I think, section 1.5, I think, where we're talking about even and odd functions. Do you remember those terms? Even and odd functions? An even function was symmetrical about the y-axis. An odd function was symmetrical about the origin. If you plugged in that negative x value for an even function, you'd get exactly the same thing you started with. Where you plug in a negative x for an odd function, and you get the exact opposite of what you started with. Remember this idea? Okay, if you don't, you're going to want to revisit that. Okay? So, kind of just said exactly what it says there, right? When you plug in the negative, you get the same thing. When you plug in the negative, you get the opposite. That makes this an odd, and this makes this an even. Right? So this is even, and this is odd. And so we're going to look at that idea now in terms of the trig functions. So what you need to really remember is that cosine and secant are even, and then all the other functions are odd. Okay, so you want to remember that cosine and secant are even functions, and the other four are odd. And I'm going to show you why. So if we take a look here, and we just think about some angle, let's say angle t. Okay, so let's just say that this is angle t right here. Okay, this is going to produce some x, y value, right? Now, if we think about cosine, cosine is the x value of the coordinate, right? So that means that in this situation, the cosine of t, the cosine of whatever angle this is equal to x. Okay, so now, if like this was 40 degrees, now let's look at a negative 40 degrees, or a negative t. What would this coordinate be? If I was it's just a reflection, right? Because I'm just going backwards the same amount. So what would this coordinate be? What are the rules of reflection? X negative y. So now if I think about the cosine of a negative t, the cosine of this negative angle, what is my x value? X. And they are exactly the same, right? Whether I plugged in the positive angle or the negative angle, I get exactly the same thing. That is why cosine is an even function. Okay? Now let's look at the same idea but with sine. So now if I take a look at angle t again, I produce this coordinate of xy. What is the sine of t? It's just y. It's just the y coordinate. Right? Now if I plug in the negative angle, the same angle but negative, negative t, what happens to my coordinate? I get x negative y. Agree? Right? The rules of reflection say if you reflect it over the x-axis, then the sign of y will change. So then doesn't that mean that the sign of a negative t is negative y? And isn't that the exact opposite of what I originally got? Making this an odd function. Okay? So this is this idea. So you need to remember that cosine and secant are even functions, and all the others are odd. You could add that to your unit circle if you wanted to add that somewhere on your sheet just to make a note of it. It is a very important idea. You do need your calculator now. Okay, so now we are going to evaluate. This is slightly different. Of course, I got the bad calculator. Hopefully you can see it. We're going to use our calculator to evaluate these, and we have to use the calculator because they're not unit circle values. So we can't do this by hand, or I guess with our head anymore. So this is a little bit different. They're giving you the angle. So what happens here is like you're evaluating the sides of the triangle. You're trying to create the ratio here. So when you think about like let's go back, the sine of, well, this is kind of a bad example. If you think about like the sine of 5 pi over 4, This y value here represents the opposite over the hypotenuse side. It represents the ratio of sides. The ratio of sides is negative root 2 over 2. So that's where this comes from, okay? So now what's happening is they're telling us the angle, and they want us to find the ratio of sides. So it's like I'm finding, in this case, with cosecant, I'm finding the hypotenuse over the opposite. Okay, so I'm finding the hypotenuse's length over the opposite's length. So it's going to give me a decimal value, which really represents the ratio of sides of the triangle, which means I am no longer looking for an angle. The angle is given. So I'm not looking for degrees. I'm not looking for radians. What I'm looking for is a fraction or a decimal value that represents the hypotenuse over the opposite side. Because of that, the mode gets a little bit trickier because the rule is a little different, right? Because you're no longer looking for a degree or a radian value. You're looking for the ratio of sides. So what the rule is whatever mode is given, that's the mode you choose. So whatever type of angle is given, that is the mode that we choose here. So everybody agree that we're given radians in these three? Okay, so in these three cases, we want to be in radian mode. Make a note of that. Okay, now, the other thing here, and let me see if this will show up. No. So the other thing we have to do, okay, I'm just going to focus on the calculator. You could write it in on your notes. Okay, so the other thing is there's no cosecant button, okay? So that kind of changes it too. Now we got to think about how do I put this into the calculator. So this is what you're going to do. I'm going to turn this off for a second. So for cosecant, it's the reciprocal of sine. And there is a sine button. So what you're going to put in is 1 over the sine of pi over 12. And you want that in parentheses. Okay? That's telling it find the reciprocal of sine. You are in radian mode because radians are given. For tangent, you are going, I'm sorry, for cotangent, it's the reciprocal of tangent. So you're going to put in 1 over the tangent of 5.7. What do you think you're going to put in for secant? Yep, 1 over the cosine of 1.6. So now everybody in your calculator, try to evaluate these. I'll give you the solutions and make sure you can get these. Jake, you had a question. What is it?
Aren't there inverse buttons for each of those?
Yes. So the other option you have is to put it in as the sine of pi over 12 and then take the inverse of it. Okay, which is telling it find the reciprocal of it. I always remember it easier like this, but you're welcome to use that method as well. Okay. Were you able to get these solutions? Everybody okay with those? Any questions so far? Okay, the last problem, I think I pushed here. Yep. So now we're still evaluating these, but now what mode should we be in? Degree, because degree is given. So now we're in degree mode. Now we have a sine button, so that one can be entered in as is. So the sine of 20 degrees, and that's something that you did in geometry, right? Did you get 0.342? Okay. Now secant, there's not a secant button, so you can put in 1 divided by the cosine of 110 degrees, or you can put in cosine of 110 degrees and then use the inverse key. Okay. Either option. You should get negative 2.924. Everybody able to get those in their calculator? And that's 4.2. Okay.